Welcome to part 8 of our AI safety series. Today, we're moving from theory to practice. How do we control what AI agents can do in the real world? As models become more capable, they're not just generating text, they're calling APIs, writing code, and even executing actions autonomously. That's powerful, but it's also risky. A single misaligned instruction could lead to data leaks, financial loss, or worse. So how do we keep that power in check? The answer starts with sandboxing. Think of it like a digital playpen. The model can act, but only inside a controlled environment. For example, if your agent needs to browse the web, give it a restricted browser that blocks sensitive domains and logs every request. Next, apply least privilege. Don't give your model full access to your system or APIs. Instead, grant the minimum permissions needed for the task. If it only needs to read data, don't allow writes. If it needs to call an API, scope it to specific endpoints. Then, add runtime policies. These are automated checks that trigger when something looks suspicious, like a model trying to download its own weights or disable a monitor. Combine this with rate limits to prevent abuse at scale. Finally, align your approach with frameworks like NIST's AI Risk Management Framework, which emphasizes governance, measurement, and continuous monitoring. Because safety isn't a one-time setup, it's an ongoing process. In this video, I'll show you how to implement sandboxing in a real workflow, configure API scopes, and set up alerting for risky actions. Because the goal isn't to stop innovation, it's to make sure innovation doesn't stop us. In Part 9, we'll tackle another big challenge, evaluations that resist gaming, because if your benchmarks can be hacked, your safety guarantees are an illusion.